Hello and welcome back for another VMK in the game development series. In this VMK we're going to continue off with the previous VMK where we're working with our GUIText class. Our GUIText class was created for actually a number of reasons. Even though it may not seem very intuitive why we want to create another class to handle text, it will make a lot more sense once we actually start using it inside of our overall framework with all the GUI controls. I will talk about this a little bit more in detail once we get things rendering on the screen. So let's first go into our program and get some text on the screen. To do that, we'll need to go into our scene class and into our initialize. Down here we have all of our GUI controls, which we'll be adding in shortly, but for now we're just going to be adding in our GUIText. So we'll add ptext into here, and also we have to go into our header file and include the GUIText file. Okay, I'm going to keep this guy here because we're going to need him. Actually, I don't know if we're going to need him, but I'm going to keep him anyway. And this other stuff we're just going to delete for now. And let's write the following code. Okay, so to start off, we're going to need to call new GUIText to create a new pointer to our GUIText class. The first parameter that we pass into the constructor is the ID number for the GUI. And we're going to use GUI underscore options underscore text resolution. The next guy is the ID number of the font that we've already loaded in and we're going to be using when we render text with this GUI. And the last parameter is the position of the text that we want to locate on the screen. The position is with respect to the bottom left-hand corner, so just remember that whenever you're trying to line things up with other controls. If we have any problems, we generate an error message. Otherwise, we'll go down here. We need to call setText so that we can specify the size of this GUI as well as what text this GUI is going to be containing. I've typed in here resolution just because this ID number here is with respect to the options menu, which is going to have some radio buttons that are associated with the resolution. But you can type in anything here while we're just testing it. After we create this pointer to our GUIText, we need to save it into our container. So we use the pushback command from our member variable here, which contains all of our controls. And once again, this control is only going to be saved inside of the menu game state because that's what we're currently rendering to the screen. So let's save this and compile him. Oh. It looks like we haven't initialized UI fancy ID yet, which means that we most likely haven't loaded in any font up above. Or no, we did up here. We have something called small ID. So let's just use this guy. Inside of our constructor. There we go. I noticed a few warnings up here. Okay, these are fine. So let's run this now. Oh, we're trying to build, but we have a problem. All right. One thing we needed to do, which we forgot to do in the previous VMK, is allocate some memory for our static member variable. You'll remember that inside of our GUIText class, we created this static member, which is going to be pointing to the std vector, which is containing all the font pointers. This variable happens to be saved inside of our scene, located down here. It's this guy here. So after we've declared this member variable, we need to associate this static member to point to him. And we can do that by going inside of the constructor of scene and making that association. So let's open up scene.cpp and locate it at the very top here. You'll notice we have a grouping of all the other static members that we're already using. So underneath this one here, let's just add in our std vector for our font pointer, and we're specifying here GUIText, and the member variable that we're going to be assigning initially is going to be null. So we're going to save this guy's pointer to be equal to null. Now after we initialize our scene, or actually before we even initialize, after we construct our scene, we'll have access to this member variable right here. So once we have access to it, we should assign our static member variable for our GUIText to point to him. And we can do that by going inside of our constructor, scene, here, and let's just do it right after we do the alpha objects. We're going to assign a static pointer in the scene graph to point to the container inside of the GUIText class. So we're taking the GUIText static member and we're making his pointer equal to the address of our member variable here, which is going to be containing our std vector of font pointers. So let's save this and compile him. Alright, so now he compiles, and if we build, I think it should be fine now. It is. That's good. Now let's run it, and we can see on our screen here we have our resolution showing up. Now, because this is an actual GUI control, we'll be able to interact with it any way we choose. However, right now, the program hasn't been written in any way to interact with it other than just showing it on the screen. A little bit later on, what we're going to do is, well actually before I talk about that, let me explain why it is that I created this GUIText class in the first place. The GUIs are all associated with a specific state that the game is running in. And as you've already seen, when the program first starts up, we go into our splash screen mode. After we go into splash screen mode, we're going to jump into our GUI menu. Actually, let me open up an image file here. Back inside VMK 38A, I showed you this overall flowchart. And it's very important to understand how these GUIs are going to work, because in the next VMK, what I'm going to do is actually start implementing this structure. So what we have here is when we start a program, we're going to go into our starting state. And this is where we see our splash screen. After it's done, we're going to go into the GUI state, the game state called menu. And this is currently where we're working to render everything to the screen. So when we see our image here on the screen here, he's actually associated with this specific state. Now when we're inside game state menu, we know how many GUI controls we need to render because we have a container that is storing all the controls that are supposed to be on this screen. So we render them and we see them on the screen. And when we have our GUIText class being used to render text, we can associate text with this specific game state. Now, here's the interesting thing. When we move from one state to another, our game state is going to change, which means that in the back end, everything is getting tracked for us. So as soon as we switch over to game state options, for instance, only the GUI elements that are associated with game state options will render to the screen. All the other ones will no longer render. So, for instance, because resolution right now is associated with game state menu, if we were to move to game state options, this won't appear on the screen. It'll still be saved in memory, but it just won't render to the screen. This is the key thing with all the GUI controls. We've associated them with a specific state inside of our game. Now, if we didn't create this GUIText class, we wouldn't be able to associate text with a specific game state, which means when we're in here, we would be rendering text to the screen, but as soon as we moved over to this state here, we would still be rendering the exact same stuff to the screen. We'd need to write some extra code to handle when we want to render certain items and when we don't want to render them. To keep things really easy and handled nicely, I've decided to create this GUIText class so that the text is associated with a specific state. just the same as all the other controls that our GUI functions are using. So that's the main reason for using this GUIText. It's really a wrapper for our font, which is a wrapper for how we want to render text to the screen. So I hope I didn't confuse you too much there, but that's it for this VMK, relatively short. So come back for the next VMK after you've studied this flow chart here, because what we're going to be doing is we're going to be implementing the structure so that we can move from one state to another using the appropriate triggers to go from one to another. And after we do that, we can then start dumping in all the different controls that we want for each of these states to allow us to manipulate from one state to another.